Okay, the next topic is curvature and radius of curvature. Curvature and radius of. Okay, now let's consider the XY axis with the origin. So say this is X, Y, and the origin. All right, now let us consider a fixed point A, and then we'll draw a curve around A. Okay, so if I say this is the point which I'm considering as reference, this is A, and we have a curve. Okay, in this curve, let us say I have one point, say P on this curve. This is P, and let me write another point over here. This is, say, Q. Okay, so the significance of these points are like this. Now if at all I try to draw a line that is the tangent to this curve at P, okay, we know that the standard notation for this tangent making an angle with the original x-axis is psi, right? This psi represents the angle made by the tangent with the x-axis. Okay, now if this PQ is very close, let's say assume that Q is very close to P, but right now I cannot draw that. The reason being, if I draw very close, I don't differentiate, right? I may not be able to differentiate the change. Okay, for that reason I have written it bit far. Okay, so I have written this slightly away from the point P. Okay, now what I do, I draw the second curve, right? The second line, which is also a tangent. All right, I want to draw that now. So the second curve that I want to draw now, let's say assume it passes through Q, and it also makes some angle with the original x-axis. Okay, let me draw it in this fashion. All right, now let me say that when I consider the point Q and I measure the angle, right, that angle is an additional small angle which is the original psi plus a delta psi. Okay, where is the delta psi? If you remember, this is the delta psi. This angle which is addition will be the delta psi. The same thing goes on the other side. This is also delta psi. Okay, now so just to make things very clear, I'll write the points which I have written so far, right? See, the AP curve is what I'm going to call as S. Okay, now if the PQ curve is very small, and I'm going to call this as the delta S. Okay, this implies if I want to write AQ, the curve AQ, then that will be equal to S plus delta S. All right, this is directly written from the diagram what we are referring now. Okay, now in addition to this, in the next part, what I'm going to do now is, right, so because of this arrangement, there is an angle psi and psi plus delta psi made by the tangents at P and Q. This is very clear, so I'm not going to write that now. Okay, angle delta psi between the tangents is called as bending of the curve, right? Depends on this. Now if you want to define, let's go to the definition directly, right? So amount of bending of a curve is the curvature. Okay, amount of bending of a curve is called as the curvature. So this is the first term which we are going to define now. So how do you define the curvature? So curvature is denoted by K, that is equal to, this is limit. You see the delta S should be close to 0. S should be as small as possible. What do you mean by delta S small as possible? The point Q is actually going as close to P as possible. Refer the diagram. So if Q comes closer and closer to P, you see that PQ, right, is delta S, which is going to be 0, right? So that's what we have written here. So K is the term curvature, that is equal to limit delta S tending to 0 of the del psi by del S, right? So this itself is defined as d psi by ds. So this is what is called as the curvature, right? Now K is not equal to 0. So, right, we have another term coming up, right? So that is the radius of curvature. Second term to be defined for today, that is radius of curvature. How to define this? This is denoted by rho, which is equal to 1 by K. So as per the definition of K, it is d psi by ds. Now it's ds by d psi. So using these two, one is radius of curvature and the other one is the curvature itself, right? For any given curve, we can always calculate the curvature and the radius of curvature. Okay, so that's the concept, how to what is a curvature and how you can use a curvature to get the radius of curvature. All right, so now what we do, we have to identify and get some equations to calculate the radius of curvature for sorry, for Cartesian format and also for the parametric format. All right, we need this, we have to derive. So the first thing that we are going to derive today before we start solving any problem is the radius of curvature in Cartesian format. All right, so that's the first topic. This is radius of curvature of, it's a Cartesian curve. All right, now let's start the derivation by drawing a Cartesian curve first. Okay, let's consider the coordinate axis like this. This is y-axis and x-axis. Now let's assume that there is a curve like this, and we will find a point P somewhere here. Maybe this is the point P, x comma y, and at that point P, let me assume that I am drawing a tangent. Okay, and this tangent makes an angle psi with respect to the original x-axis, and let me consider a fixed point A over there because this is what we discussed earlier. Okay, fine. For this given curve, uh, let's start with the normal representation, right? That is AP. This curve length AP is, it's a curve, so I mark a curve over there. This is S. All right, and let psi be the angle made by the tangent with respect to the x-axis. Again, I'm not going to write that because we are very familiar with these concepts now. Okay, now what is tan phi? We know from basics. So this is tan phi is nothing but, all right, this implies tangent of this psi is nothing but, if you remember, This is simply the derivative dy by dx. Okay. Now what I do, I ultimately, in order to define the radius of curvature, I need to differentiate this whole function with respect to s, right? So let's do that. Differentiating with respect to s. In the sense, the above function I'm going to differentiate with respect to s. So let's do that. So that is d by ds of this function, that is tan psi, is equal to, it should perform the same differentiation on both sides, d by ds of dy by dx. Okay, so we started with the differentiation, so I should perform the same thing throughout. So differentiation of a tan phi is nothing but, this is, if you remember the basics, it's a secant square of psi into, see, the psi is a function of s, so I have to perform d psi by ds. This is so this is equal to, on the right hand side you can see that we are performing the d by dx of that function into dx by ds, because d by ds cannot be directly applied, so I'll write d by dx of dy by dx, like what I did earlier. Tan phi becomes secant square phi because we differentiated with respect to x first. So this is dy by dx into, now you write the second term, like d phi by ds, now you are going to write the dx by ds. Okay, but I know that what is dx by ds? It's a variation of x with respect to s, right? That is nothing but, from the curve I should understand that whenever d the change in x with respect to s, that becomes the cos function. Okay, so let me substitute that. So this is right. I'll call this is equation number 1. So but I know something. Whatever I know, I'll write. That is dx by ds is equal to, this is cos psi. Right? This is very basic. We already know this. And also we know something else. That is, if you have d psi by ds, this is 1 by rho. Okay, because finding the rho is our target, I'll write it as d psi by ds, which is k is equal to 1 by rho. Anyway, we got this. So this is what I call as equation number 2. Now put 2 in equation number 1. Okay, so when we do that, we are having the secant square psi on one side into, see, d psi by ds already written as 1 by rho in equation 2. I'll substitute. This is equal to, so there is a d by dx of dy by dx, that's going to generate a d square y by dx square into the dx by ds is cos psi. Okay, now you see the cos is going to the other side. Cos can be written as 1 by secant. That goes to the other side as secant itself. So already there is a secant square. So when the cos going to other side, this becomes secant cube psi. Okay, I got a secant cube psi into 1 by rho. This is equal to, or okay, let me say one step. Let me move the rho to the other side now itself. So what happens? The rho goes to other side as simply 1 by rho becomes rho into d square y by dx square. So what can I do now? This implies my intention is to calculate a rho, right? So okay, let's keep the rho on this side. So rho is equal to, this is secant cube psi divided by d square y by dx square. Right? Let's say this is the equation. But now what I do, I try to modify this, right? Because I don't know the psi and I don't want to keep calculating the psi each time I want to calculate the rho value. So for that reason, what I do, I use a trigonometric identity. So that is secant square theta is equal to, this is 1 plus tan square theta. All right, so I want to use this identity to get a tan now, because secant is difficult to handle. Tan is easy because I can calculate the tan of any angle by simply differentiating that, right? Any curve, right? You calculate you differentiate that curve, means what you get? You get the slope of the tangent, which is the, right, tan theta. Okay, so but I don't have a secant square here, I have a secant cube. So what do? I modify this now. So this is equal to, I slightly modify this. See, this is, I bring a secant square and I cancel the square by taking a root, so that is 3 by 2. So 2 and denominator 2 will cancel, you are still left with the power 3. Okay, yes. Now, so this is equal to, sorry, this divided by d square y by dx square. Anyway, I am writing this now. So this means rho is equal to, see, secant square is nothing but, it's a 1 plus tan, right? So I'll write 1 plus tan square. It's not theta anymore because we are dealing with the psi. Now this thing raised to the power 3 by 2 whole divided by the d square y by dx square. Okay, d square y by dx square. Now, but I know something already. What is tan psi? Tan psi is dy by dx. So this is tan square, so dy by dx whole square. So I can write this as 1 plus dy by dx the whole square whole raised to the power 3 by 2 whole divided by, this is d square y by dx square. See the difference between the term in the numerator and the denominator. Numerator dy by dx whole square, you find a differentiation and square the term. The denominator is nothing but, you should differentiate the whole term twice. 2 times you differentiate, then you get this. Okay, so that's the equation for rho. Anyway, so in short, you can in there is a short form in differentiation. So if you call, say, dy by dx as y1, first differentiation, and d square y by dx square as y2. If you represent this, then the rho can be replaced as 1 plus y1 square divided by, sorry, there is a power 1 plus y1 square. Y1 is dy by dx. Okay, so dy by dx square, that's y1 square whole power 3 by 2 divide by, this is d square y by dx square is simply y2, right? You can remember using this notation. So this is the equation that is required to calculate the radius of curvature for any given curve which is represented using the Cartesian format. Okay, so this is important equation we need to remember. Okay, after this now we will solve or we'll derive the radius of curvature for a parametric curve. All right, this is the next thing. We need to use this equation to solve certain problems. All right, so this is radius of curvature. So radius of curvature for parametric curve. So now we know that the parametric curve is a straightforward xy curve, but x equal to a function of time. So x equal to x of t, and the y is also a function of time, so we denote it as y of t. If this is the parameter, right, so both x and y depends on the time as a parameter, then the curve y is equal to f of x will be called as the parametric curve, right? So then y is equal to f of x is what is called as the parametric curve. All right, now what we want here, we want to represent the parametric curve and find its radius of curvature. But y equal to f of x is actually a Cartesian curve. We already know that, right? So for Cartesian, curve, I know the rho equation. Rho is equal to, this is 1 plus y1 square whole to the power 3 by 2 divided by, this is y2. Okay, y1 is dy by dx, y2 is d square y by dx square. We already know this, we just have derived this. So we are now, what we are trying to do here, we are trying to represent these y1 and y2 in terms of the parameter. That's all. Just replace it with the parameters, you will get the answer. So what is y1? Let's try to write. So y1 is equal to dy by dx. So what is dy by dx? Now I need to do this in a different way, because dy by dx is not available directly, because y is a function of time and x is also a function of time. So because of that, now I have to make a small difference in the way of representing this. So I can do dy by dt for sure. Okay, but the next term is nothing but it should be dt by dx, because dt cancels and I can write this. But what I do now, this is, I slightly modify, this is dy by dt divide by dt by dx I don't know, but dx by dt I know. That's why I'm bringing it into the denominator. So what is y1 now? Y1 is nothing but, this is numerator, I'm calling it as y dash, denominator I'm going to call it as x dash. Okay, y dash and x dash, where I'll make it more clear, where what is y dash? Y dash is dy by dt, and what is x dash? X dash is dx by dt. Okay, so y1 is written in terms of the parameter like this. Okay, let's go ahead. I also have the term y2 in my equation, so anyway I'm going to call this is 1. Let's call this part as equation 2. Okay, and in equation 1 denominator I have y2, so let's calculate a y2 now. So what is y2? Y2 basically it is d square y by dx square. Okay, that is nothing but the d by dx of dy by dx, isn't it? Now you see that this dy by dx just now we calculated from equation 2. So that is, write the outside d by dx as it is. Inside dy by dx I am writing from equation 2. So from equation 2 I am writing this, dy by dx is y dash by x dash. So if you remember, this dy by dx of this has to be performed in such a way that this is a function of what? It's a function of the d by dx. It's a function of time. I should bring the time over there. So what I do here now, so see, denominator, that it's a rule of differentiation. It's called as a quotient rule. So whenever you have a quotient present in your equation and you want to differentiate it, write the denominator first, that is x dash. differentiate the numerator. Differentiation of a numerator is y double dash, because y dash is already there. I should differentiate and write y double dash. Okay, then subtract, minus, write the numerator as it is, that is y dash, differentiate the denominator, that x dash is there, it becomes x double dash. Okay, whole divided by this is x dash, that's the denominator, the whole square. Okay, yeah, okay, I missed one term there. I'll just write that term, that is dt by dx, because it's a function of time, right? So I want to bring the time over there, that's why I need to do this. So what is dt by dx? It's 1 by x dash, so I have to write a 1 by x dash over here, right? It's simply the chain rule being applied, and also we are using the quotient rule here to simplify this. Now, so this means this is equal to, this is what, this is still y2. So what is y2? Y2 is equal to x dash y double dash minus y dash x double dash divided by, so the denominator has 3 times x dash square into x dash. I can write it as x dash cube. Okay, right. So here also let me make some things very clear. So what is a x double dash? X double dash is nothing but d square x by dt square. See, the differentiation is happening with respect to t. Similarly, I have a y double dash, that will be d square y by dt square. So I'm using this notation in my derivation. Okay, so I got this y2 now. So let's call this y2 by equation number 3. So you see here what I'm trying to do now. I have equation 1 already, which is a standard equation. I need to substitute equation number 2 and equation number 3 in equation number 1 to get the required parametric format. That's all. So this is 3 and equation number 2 in equation number 1. Only this is what I am supposed to do now. Okay, so that is rho is equal to, see the numerator is 1 plus, right, 1 plus, it is y dash square. So y dash is just now calculated, that is y dash by x dash, sorry, y1 square, y1 is y dash by x dash, that's why it's a square, whole raised to the power 3 by 2. That's the first term. And in the denominator, it is simply y2. Okay, let's substitute the y2. Y2 is nothing but, this is x dash y double dash minus y dash x double dash whole divided by, this is x dash whole cube. Okay, now we know one rule in mathematics. If you have a denominator of the denominator, that goes to the numerator. In the sense, this x dash cube will go to the numerator. So that can be written in the following fashion. So this is 1 plus, this is y dash by x dash square whole power 3 by 2 into the denominator of the denominator, that is x dash cube whole divided by x dash y double dash minus y dash x double dash. Okay, now in the next step, our intention here is to simplify if possible. Okay, so what I try to do here is I'll try to take a common denominator, right, in the numerator, right? So there is a numerator term, I'll try to take the common denominator of that, and let's try to simplify that. Okay, what happens now? This is equal to, see, I'll try to write this as okay, so this is 1 plus, there is a y dash Okay, this can be written like y dash square by x dash square, but this x dash square can be considered as the common denominator. Okay, so what I try to do here, this is y dash square by x dash square inside the bracket whole power 3 by 2. Rest of the terms remain same as of now, because we still have not simplified this. Whole divided by, the denominator still looks like x dash y double dash minus y dash into x double dash. Okay, in the next step I'll take the common denominator, that is, this is x dash square plus y dash square whole divided by x dash square. That's what is inside this bracket, whole power 3 by 2 into x dash cube whole divided by, this is x dash y double dash minus y dash x double dash. Okay, now since you have a common denominator, you can split the term. That is, I'll write only the numerator like this. This is x dash square plus y dash square. See, only this term I keep in the numerator, power 3 by 2 into x dash power 3 whole divided by, so the denominator of the numerator I'm going to write in the denominator, that is x dash square to the power 3 by 2. Okay, into this other term, that is x dash y double dash minus y dash into x double dash. Now what is the advantage of writing like this? This is, you can see here, this 2 and this 2 will cancel. When that cancels, what you are left with, you are simply left with x dash cube. So can I cancel that? Yes, x dash cube and x dash cube can be cancelled, right? So after that, whatever remains here is your final answer for the value of rho. So the rho is equal to, now let's write this. So this is x dash square plus y dash square whole to the power 3 by 2 divided by, this is x dash y double dash plus, not plus, minus okay, so this is minus y dash x double dash. Okay, so this is the final answer whenever the equation is given in the parametric format. So two things are pretty important, right? So both equations we have derived. Now we will be solving both type of problems now. Okay, so first one, let's try to solve a simple problem. We just have to get adjusted to understanding that what we need to find. Okay, so find the radius of curvature of a given curve. That will be the problem. So y is equal to, this is a very simple problem, a log of secant of x by a. This is a question. All right, so whenever you see that y is equal to function of x, y is equal to f of x, this looks like that. Okay, I don't have any parameter t or theta in this, so this is not type 2, this is the type 1, which is you can find the radius of curvature rho is equal to, simply by calculating 1 plus y1 square whole to the power 3 by 2 whole divided by, this is y2. Okay, this is the equation if the given curve is Cartesian. Cartesian in the sense y should be a function of x only, right? A will be a constant in this case, so I don't have to worry that it's a constant. Log of secant of x by a, I can see that it's a function of x. So y is equal to f of x means this is Cartesian, right? Okay, so what you do, we know the y, directly calculate y1, right? What is y1? Differentiation. This is dy by dx. That is equal to, given function you differentiate. So a is a constant, log of something is 1 divided by secant of x by a into differentiation of secant is what? It is secant of x by a into tan of x by a. I'll write here, in secant of x by a into tan of x by a into differentiation of x by a is 1 by a. All right, I can see that gets cancelled. Also, I cancel secant x by a, secant x by a. So what you are left with is y1 equal to tan of x by a. So therefore, y1 is equal to, this is tan x by a. Once you get y1, I can see the equation. In the equation, I have a y2. So calculate y2 now. Therefore, y2 is equal to, y2 is equal to, it's d square y by dx square. Means whatever tan function you got as y1, differentiate that once again. Okay, so tan x by a is secant square of x by a, right, into differentiation of x by a is 1 by a. So I can call it as secant square x by a divided by a. That's what this is, y2. So now what I need to do, therefore substitute. Therefore rho is equal to 1 plus y1 square. y1 is nothing but tan. So this is tan square x by a, right? Tan square of x by a, 1 plus y1 square whole to the power 3 by 2 divided by y2. What is y2? y2 is 1 by a times secant square x by a. Okay, this is what I get. Now I need to simplify. So what is 1 plus tan square theta? If you remember, just now we have used this. 1 plus tan square theta is secant square theta. So I can write this is secant square of x by a. But whole power 3 by 2 is still there. Whole to the power 3 by 2. Now you can see that this square and this power 2 will get cancelled. Okay, then denominator is anyway 1 by a will go to the numerator as a divided by, this is secant square x by a. Okay, so what happens now? This is nothing but secant cube of x by a, there is a coming up in the beginning, divided by secant square of x by a. So you can simply, right, this square gets cancelled with this, only one secant remains. So your final answer, therefore the rho is equal to a into secant of x by a is the answer. This is the required radius of curvature. Okay, next problem. Okay, I'll give the statement now. This is find a radius of curvature of x cube plus y cube is equal to 3 times a into x into y at a point. The point is 3a by 2 comma 3a by 2. So we need to find y1, that is dy by dx. We need to find d square y by dx square, that is y2. And since you can see this given function is a Cartesian curve, I just have y is equal to f of x. There is no other parameter t or theta present. That's why I should use the same equation. Rho is equal to 1 plus y1 square whole power 3 by 2 divided by y2. y1, y2 should be calculated first, right? Then we need to proceed. So we need to start differentiating this given curve. So let's write the curve once. So the given curve is x cubed plus y cubed is equal to 3axy. So the given function is not in the y is equal to f of x form. So for that reason, I cannot directly get the answer, but definitely I can do this. So what we do, we differentiate with respect to x. That is, x cube becomes 3x square plus y cube becomes 3y square into dy by dx. Okay, this is equal to, see, the 3a is common. When you take it out, what you have? This is a product. So x first term into differentiation of the second term dy by dx plus the second term, that is y, into differentiation of x, that is 1. Okay, now I can see that the 3 which is there in each of the term gets cancelled. 3 3 3, it's gone. Now in the next thing, okay, let's bring the terms containing dy by dx to the same side. Okay, so here I have, okay, let's expand and write first before we bring it to the same side. So x square plus y square dy by dx is equal to, this is ax dy by dx plus ay. All right, now I'll try to bring the terms containing dy by dx to the same side. So that is y square dy by dx minus ax into dy by dx. The term from the right comes to the left, so it is negative, is equal to, on the other side, there is ay. So I'll write the ay as it is, minus x square will go from the left to the right, so this becomes negative x square. All right, so let's take the dy by dx common from the left hand side. So I'm left with y square minus ax, and on the right side I have ay minus x square. So therefore I need y1. y1 is nothing but this dy by dx, that is equal to, take the y square minus ax to the denominator of the right side. So what you have, ay minus x square divided by y square minus ax. Okay, call this as equation number 1. I got y1. All right, that's y1. I can directly substitute this in the given equation now. Okay, given equation of rho. But in the same equation I have a y2 present, so I need to calculate y2 now. So what is y2? d square y by dx square. So just now we got equation 1. I need to differentiate that once again. So as you can see, this term is it's a quotient. So I need to apply the quotient rule to simplify this, right? So that means denominator is y square minus ax. Denominator into, right, the differentiation of the numerator. So numerator differentiation is a, y becomes y1 minus x square becomes 2x. Okay, that's the first part minus, it's still in the numerator only. The first term is ay minus x square into differentiation of the denominator. Differentiation of the denominator will be y square is 2y into y1 minus, this is simply a. This whole thing is the numerator divided by denominator square. This is the standard rule of differentiation by applying the quotient rule. So y square minus ax the whole square. Okay, now you see that there is actually a specific point given, right? Let us try to apply the point now. So when we apply the point, this becomes very easy for us. Okay, so let me call this is equation number 2. So you see that they are not asking at a general point, they are very specific about this, because they ask at a given point 3a by 2 comma 3a by 2, which means every x and y value what you have in equation 1 and equation 2, right, you need to put this value. Okay, so this is how you proceed. So at the point, at a point 3a by 2 comma 3a by 2, this is the given point. In the sense, I am supposed to replace every x comma y by this value. Okay, so let's calculate y1 first. At this point, let me calculate y1. Y1 is equal to, this is, right, you can see that this is ay. So y1 is what? A into y. Y is 3a by 2. Okay, every x and y should be replaced by 3a by 2. So ay minus x square, x is 3a by 2 the whole square, divided by y square. What is y square? Y square is 3a by 2 the whole square minus a into x. So a into 3a by 2. Now if you see the numerator and denominator, they are same but opposite in sign. Correct? So this whole thing cancels with this as minus 1. You see the sign is different, that's all. So it's actually minus 1. So the answer y1 is minus 1. Right? So in the sense, when I apply 3a by 2 comma 3a by 2 to this equation, that is in this whole part, you see that there are several y1s coming up. See, y1 here, etc. What you put, that value is equal to minus 1. Okay, that's what is the meaning of this. I just have to substitute this value over there. This is minus, right? You can see it's actually minus of, see, the a into 3a by 2 is here with the sign minus. Minus of this is on this side with the plus, which means they are opposite. That's why they cancel each other with minus 1. They are negative of each other. Okay, if you want, you can actually extend this and write in it by one additional step. I'll just write that now. So that is equal to, right, this is equal to, right, anyway, let me not cancel this. Let's say that this is not cancelled, this is as it is. What I do, in the numerator I'll take minus 1 outside. Minus 1 into, see, when minus goes out, the 3a by 2 square comes here. So minus of minus will be plus. That's why the 3a square by 2 comes here. Okay, whole divided by the term as it is. This is 3a by 2 the whole square minus 3a square by 2. Now you see, what is this? They will definitely cancel, right? They are same. What is left? Minus 1 is left. Okay, so like this, the y1 becomes equal to minus 1. So similarly, I need to substitute and calculate the y2 value, right? And y2 is equal to, what you are supposed to do, put everywhere, wherever you see a y, it should be 3a by 2. So just look at the term. This is, the first term is 3a by 2. This is y square. minus ax minus a into 3a by 2. Okay, this is the first term. Second term, a into y1, a into minus 1, because y1 is that, minus 2 into 3a by 2. So where I'm substituting? I'm substituting everything in equation 2 here. So this equation 2 I'm replacing. Okay, so let's do that. So this is the term minus the next term ay. So this is a into 3a by 2 ay minus x square. X square is 3a by 2 the whole square. Sorry, into the next term is 2y into y1. So this is 2, y is 3a by 2 into y1 is minus 1. Okay, minus a. This is the numerator part, whole divided by, there is a denominator to this term, that is y square. Y square in the sense I am supposed to write 3a by 2 the whole square minus a into x, a into 3a by 2 the whole square. Okay, now let's simplify this quickly. Now I have the first term, that is becoming 3a square by 2 minus 3a square. This is 9a square minus this. So I have 3a square by 4. That's the first term. Into the second term becomes minus a minus 3a. Correct? So this could be minus 4a minus, let's say the second term, this is minus of 3a square. So this is a negative of that term. So I have minus 3a square by 4 into, this is minus 3a minus a, so minus 4a. Okay, this whole thing divided by, so denominator 3a square by 4 minus a into, this is 3a square by 3a square by 4 the whole square. Okay, now so what happens to the numerator? This is minus 4 and 4 will cancel, so I have minus 3a cubed. Minus of minus will cancel, one more minus is there, so this is minus 3a cubed whole divided by 3a square becomes 9a to the 4 divided by 4 square is 16. Okay, so this, when you reduce, the y2 becomes equal to minus of 32 by 3a. This is the answer. Okay, we got y1 and y2. So the final step here is to calculate this. Therefore rho is equal to, this is 1 plus y1 square whole to the power 3 by 2 divided by y2. So substituting this, 1 plus y1 is minus 1, so minus 1 square is plus 1 to the power this whole divided by y2 is minus 32 by 3a. Okay, so now you can see that 1 plus 1 is 2, so 2 power 3 by 2. Okay, I can write this as, this is equal to 2 to the power 3 by 2 is a 2 root 2. Okay, 2 root 2, denominator has a 3a which goes to the numerator into, this is divided by minus 32. So 2 cancels with the 32 as 16, right? So root 2 cancels with 16 as 8 root 2. So the final answer I can write, this is minus 3a divided by 8 root 2. Anyway, definitely we can use a calculator and simplify this term. Minus 3 by 8 root 2, you will get a number, right? Real number that you can write into a. Okay, but as far as the method is considered, till here is the final answer for this question.